Hi, my name is Robin Rarick, and my video for ABE 170A is Contaminants of Emerging Concern and Drinking Water Safety. It is well known that safe drinking water is necessary to human health and to minimize the spread of disease. The United States has addressed this need for safe drinking water by enacting the Safe Drinking Water Act, or SDWA, of 1974, which was later amended in 1986 and 1996. The SDWA mandates that municipalities serving populations of 25 people or more regulate dozens of specific contaminants and monitor the parameters of hundreds of other water quality aspects. Required testing, treatment, and regulation of chemical and biological contaminants has ensured that Americans have access to safe drinking water, and for the most part, Americans have enjoyed safe drinking water free of harmful levels of contaminants. However, there is evidence of new or emerging contaminants in water which warrants additional examination and perhaps appropriate action to ensure the continuation of the safety of Americans' drinking water. According to the EPA website, contaminants of emerging concern, or CECs, include pharmaceuticals and personal care products, which are making their way into water sources to serve as new pollutants and a cause for growing concern. In this video, we explore emerging contaminants in drinking water and the risks associated with these contaminants. We'll also examine how they're currently being considered in the context of water treatment and regulation. The water we drink can come from surface waters, such as lakes and rivers, or it can come from groundwater or aquifers and pumped out via wells. In either case, there are many substances that can pollute drinking water, rendering it unhealthy for people to consume. The EPA's website categorizes the various types of pollutants as microorganisms, disinfectants, disinfection byproducts, inorganic chemicals, organic chemicals, and radionuclides. Microorganisms are living animals, such as bacteria and viruses, that act as pathogens to cause a variety of illnesses or diseases in people if consumed even in small quantities. Three common microbes are Giardia, Cryptosporidium, and Legionella, shown here. If ingested, they can cause illnesses such as diarrhea, vomiting, headaches and cramps, and even pneumonia, as in the case of Legionella. These pathogens can occur naturally in water or enter the water system when human or animal fecal matter waste is present. In addition, soil runoff can also allow pathogens to enter the drinking water system. Disinfectants such as chlorine are intentionally added to drinking water to control microbes. However, they also contribute to pollution in drinking water. High levels of these substances and their byproducts have shown to increase the risk of certain cancers and can interfere with the proper functioning of the liver, kidneys, or central nervous system. In addition, they can cause anemia in small children. Inorganic chemicals, such as heavy metals, mercury, lead, arsenic, etc., and compounds containing nitrogen, such as nitrates and nitrites, are also toxic to people if consumed in high enough quantities or smaller quantities over time. These substances appear in drinking water as a result of industrial discharge from refineries, erosion of natural deposits, runoff from discarded paints, batteries, and other household items, and from corrosion of pipes and plumbing materials. Ingestion of these chemicals can cause liver and kidney damage, gastrointestinal illness, increased risk of cancer, circulatory problems, hair loss, and even death. Organic chemicals include pesticides or herbicides, solvents, degreasers, and petroleum byproducts. They enter the drinking water system through runoff from landfills, leaching from plants and cattle, discharge from refineries and chemical factories, and leaching from storage tanks. These organic chemicals can cause liver, adrenal, and kidney damage, reproductive problems, immune deficiencies, thyroid problems, increased risk of cancer, circulatory problems, and nervous system damage. The last category of water pollutants is radionuclides. These substances are mostly naturally occurring and come from mineral deposits in the earth. Erosion of these deposits introduces radium and uranium into the water supply, and further radioactive decay of these elements releases radioactive particles such as alpha and beta into the water. Radioactive substances can increase one's risk of cancer and can lead to kidney problems due to their toxicity. For each of the contaminants in these 5 categories, a maximum containment level, or MCL, is listed on the EPA's website along with the MCLG, which is the maximum containment level goal as established by the EPA. Water treatment procedures are in place to ensure that these contaminants are at or below the levels established by the EPA for safe consumption. The current treatment process of water is presented here and includes several steps. First, the water is pre-treated and screened from the removal of physical debris and aerated to remove gases, minerals, and chemical solvents that may be present in the water. Chlorine may also be added at this point to kill microbes. The next step involves coagulation to remove substances such as dirt, metals, and small solid particles that are suspended in the water. By adding coagulants, suspended particles clump together, sink to the bottom, and are filtered out. The sedimentation step involves the settlement and removal of heavy particles while allowing the clear water to pass. The clear water is filtered through sand, gravel, and charcoal that remove the smallest particles. Then the water is disinfected again by the addition of chlorine, which kills pathogens that still might remain in the water. This overall process has been effective in providing water that is safe to drink. However, there are other contaminants showing up in water that are currently being examined in terms of their potential to cause harm. These substances warrant cause for concern in that the current water treatment process does not remove them. They are contaminants of emerging concern, or in general, CECs. Published literature as recent as the late 1990s and early 2000s has provided evidence of growing attention and concern regarding new categories of substances identified as pollutants in aquatic and drinking water systems. CECs, or contaminants of emerging concern, have the potential to adversely affect aquatic ecosystems, and they make their way into surface waters, which are treated to be used as drinking water. This group of compounds includes not only pharmaceuticals such as hormones, steroids, antibiotics, and antifungal agents, but also includes fragrances, sunscreens, and many other personal hygiene products. These substances are now being detected in the water system due to their increased concentrations and the increased sensitivity of analytical instrumentation. They are now being detected in quantities that may pose a problem to the health of humans and to the environment. Much of the concern is that these substances are unregulated and their health effects to human and the environment are largely unknown. PPCPs, or personal care products, in the system come from the excretions of people or animals that have taken hormones, steroids, or antibiotics as treatment for an infection or illness, or when people dispose of unused medications by flushing them down the drain or toilet. In this way, they are introduced into the environment through sewage systems. Also, when people discard unused drugs by throwing them in the trash, the substances end up in landfills and are leached out and end up contaminating water supplies. One harmful effect of PPCPs in the water system is that they can act as anti-infectives, which means that they have the potential to disseminate anti-infective resistance in bacteria. Over time, certain bacteria will adapt to chemicals used as antibiotics and develop a resistance to them. While some substances can possibly break down over time, there are some that won't, resulting in their persistence in the environment. Buildup of these substances over time affects the environment in ways that are just now being recognized, and the extent of their threat is a new source of debate. While the bioactive pathways of drugs in humans are known, they are not well understood when it comes to animals that will come in contact with these drugs in the environment. In essence, the effects of chemicals on animals may be totally different than their known effects in humans. It's troubling to consider all the ways that aquatic life can be adversely affected when biological ramifications are unknown. Even at very low concentrations, one can speculate that exposure to these compounds could result in profound changes, which may take place so gradually over time that they're not fully recognized from natural events. Subtle behavioral changes or genetic alterations could result from chronic exposure to pharmaceuticals over time, and could be detected by conducting generational studies on life cycles of animals. In response to this emerging threat, the EPA is taking a four-pronged strategy that is: One, aimed at strengthening scientific knowledge by funding research programs to better understand the issue and monitoring occurrences of PPCPs in the water system. Also, establishing analytical methods or protocol to detect small amounts of substances is important to knowing the extent to which water is carrying PPCPs. The second strategy is improving public understanding, which goes along with the third in terms of building partnerships for stewardship. Making information available to people via their website and publications could raise awareness and enable partnerships with the community to aid with mitigating the problem. One community problem is pharmaceutical take-back programs. These programs are designed to allow the general public to drop off their unused prescriptions or over-the-counter medications so they can be disposed of properly and not end up in landfills or down the drain to be taken up into the water system. The fourth strategy is taking regulatory action when appropriate. By studying the healthcare industry to identify best practices that would reduce the amount of pharmaceutical discharges to water, we can take appropriate action. In addition, the EPA has established the third Contaminant Candidate List, or CCL3. According to their website, this new process builds on evaluations used for previous contaminant candidate lists and was based on substantial expert input and recommendations from the National Academy of Sciences National Research Council and the National Drinking Water Advisory Council. This list contains contaminants that are not currently subject to drinking water regulations, but are known to be present in public water systems and may eventually be subject to regulation in the future. Test America is one analytical testing laboratory that serves the southwestern United States. Test America and its affiliates are adjusting to the EPA's anticipated mandate and to meet the additional testing needs of its clients who require water analysis. By expanding its service to include protocol for the testing of dozens of substances that fall into such categories as steroids, hormones, pharmaceuticals, antibacterial agents, and surfactants, Test America is recognizing the need to monitor these substances and has ramped up its services to include these methods. In conclusion, safe drinking water is a high priority for human health. However, many excellent substances for treating disease and other ailments are creating new cause for concern, as they are being introduced into the water system through various waste systems including home, hospital, agriculture, and industrial sewage. These substances are mobile through our water system and are persistent in their resistance to degrade. The EPA has recognized many ways that these substances can be threatening to the health and safety of people, both directly and indirectly, as well as animals. The EPA is working to study the problem for better understanding and to establish testing and treatment protocol for the drinking water safety. While this is a newly recognized program, it warrants exploration and mitigation to keep water safe for drinking.